Welcome to the Maintainable Software Podcast, where we speak with seasoned practitioners who have helped organizations work past the problems often associated with technical debt and legacy code. I'm your host, Robby Russell. On this episode, we are joined by Robert Meaney, who is the head of testing and a test coach at Poppulo, based out of Cork, Ireland. Robert Meaney, welcome to Maintainable.
Thanks very much. Delighted to be here.
So in your team software development process, where does your role as head of testing come into play?
So as head of testing in Poppulo where I work as a test coach across 8 product or development teams. And what I do is I work with each of those teams and the team leads on those teams to identify what their quality goals are. And then I work closely with them to identify how they can achieve those goals in different ways. So there's a lot of things that we work on. We work on risk analysis, breaking stories and work down into small testable chunks, identifying risks, determining what's the most appropriate way to mitigate those risks. Also work on building skills and knowledge around testing, whether it be exploratory testing, load testing, security testing, all those different kinds of things. And I actively work with the teams to look at their architectures, design testability into the system, look at things like observability, facilitate things like testing in production and things like that. So it's a holistic approach to, I suppose, impacting quality at a team level. So it's not just, testing at the end of a cycle. It's talking about how do we take the work in from large goals? How do we break it down? How do we ensure we understand it well enough? We understand the problem we're trying to solve for our customers. How do we know when we're being successful in solving that? Breaking those large goals into small, tangible chunks and ensuring we're delivering small, valuable chunks frequently with the right instrumentation in place to give us that feedback, but also building in testability and things like observability so that when we do get these things into production, we can firstly decouple deployment and release, but once we have them released and we go into beta or whatever, that we can capture information around actual users' behavior as well as talking directly to the customers, taking that feedback on board and feeding that back into our quality approach.
So is it safe to assume that the organization you work with, you're not in the MVP startup mode anymore? You've been established for a while.
So that's an interesting question. So we've got a range of different products, I suppose, at different stages of maturity. So we have kind of a legacy product that we've been working on for maybe 20 years. That's mainly a monolith with a number of microservices hanging off it. But then we have some new products that are built primarily in microservice-based architectures. And we also have a very, very new product that's entirely cloud-based, again, based on a services architecture. So there's a complete diversity of challenge there across those different teams, So each of those differing contexts have different risks and challenges associated with them, which makes the job very interesting.
I bet. You touched on helping these approximately 8 product teams in your organization and helping them establish what their quality or goals are. What does that mean besides no bugs? But that's probably not a realistic expectation. So
that's not a realistic goal necessarily. But some of the things that I do, and there's a project ongoing at the moment where I actually work with the teams to look at their feedback cycles or feedback loops, whether that be the reliability of their end-to-end tests, whether that be the reliability of their production alerts and monitoring systems, the availability of their test environments, the amount of rework. So there are 4 things at the moment that I talk to each of the teams on a daily basis about. Another interesting metric that we look at is customer impacting issues and the mean time to recovery from them. So we're looking at failure rate and the time that the customer is impacted. So they're all things that we discuss regularly, and each of the teams has their own quality goals and indicators as well. So we have discussions about that because, as I said, the contexts are quite different. So for the monolith teams, the mean time to recovery is quite a bit longer than those in the microservices. So we have to tailor our approaches and identify different things depending on the context.
Do you have established SLAs amongst your teams? I'm assuming their products potentially interact with each other.
So that's something we're actually currently working on as well, is actually identifying SLIs, SLAs, and SLOs between the teams. So we haven't done it to date, but it's something we were discussing this week. It's an initiative we want to work is defining the boundaries and the contracts between our various contexts, as we call them, which are our development teams, defining those contracts and boundaries very, very clearly, treating each other as customers, and then defining SLOs, SLAs, and SLIs so that we can get a better idea of how we're achieving in terms of our internal customers.
You mentioned observability How do you define that? I'm just thinking for developers out there that might not be that familiar with that terminology.
So there's a few different viewpoints. So my background is in electrical electronic engineering. So I studied that in university. So when I studied that, there was the idea of control theory and all this kind of stuff. So when we talked about testability back then, there was two components to that, generally controllability and observability. So controllability in that context was the ability to be able to control all the variables that influence the behavior of a system, whereas observability was the ability to be able to observe all the interesting things happening, either from a black box perspective or within the system itself. It was essentially about seeing the inner workings and being able to see how the system works. So I took that definition and kind of started applying that to software as well, maybe 7 or 8 years ago. And I started getting real focus on testability. So in that regard, at the time, I looked at it from a testability perspective in terms of pre-production. Let's see if I can see the inner workings of the system, whether it be through logging, whether it be through various kinds of instrumentation and checks, all that kind of stuff. Like one of the earliest examples I had about 9 years ago was of working very closely with a developer on a safety automation system that was life critical. Huge amounts of difficulty with very difficult to reproduce bugs. They were taking days and days to debug because it was a 3D visualization system, very, very complex interactions with the UI and so on and so forth. So we were losing huge amounts of time and we couldn't just ignore them because, as I said, it was a life critical system. So when I worked with him one day, he was saying, why can't we just actually instrument the code so every interaction with the UI and every action that you do while you're using the tool actually gets written out to a log? And that spark kind of set something off in me that said, testability really is a key here, because after making that simple change, we started being able to reproduce these almost impossible to reproduce issues within minutes and just send files to developers and they could reproduce issues like that. That got me going into observability. But in the last few years, it's kind of had a change in meaning in some regard, and it's gone more towards, when we talk about observability, we think more about it in terms of monitoring and the testing and production and stuff like this. And when we talk about it in that context, it's slightly different in that it's a means of allowing developers and people building and operating the system to understand the system, to understand the inner workings of the system, to be able to explore the unknowns about the system. So earlier in my career, we were all about monitoring, we were all about alerts and all this kind of stuff, synthetic monitoring, various things like that. But more recently, and again, I'm a big proponent of this, we started adding instrumentation to allow us to go in there and ask questions of the system in real time to uncover and explore our production environment and understand what our users on an individual basis are actually experiencing, as opposed to monitoring, which is kind of a binary thing. It says, like, is the system up? Is the system down? What I found with adding observability now is that it's allowing us to go in there and actually look at all kinds of patterns and analyze the data and see unusual trends and isolate defects in production by just getting to know our data and investigating and looking into it and digging into it and seeing, why does this particular customer have a spike here, and all that kind of good stuff. So it's been a bit of a change, as I said, over the years, from something that was purely pre-prod, help me testing, to something that is now a core part of how we operate our production system, how we understand it, and how we continue to improve it.
What types of tools are you using to help track observability in your software?
So we have a lot of different tools we're using, from Zipkin and Sentry to obviously things like Kibana and stuff like that. So we use structured logging and the likes of Kibana to slice and dice our logs and good stuff like that. But it's all, the technology is kind of, and the tooling isn't as important as asking the questions early and designing your systems with observability in mind. So adding the correct types of instrumentation to the system as you build it, that allows you then to ask those questions when you actually push something into production. And what's been very interesting for me recently is a further evolution again on observability, in terms of, I'm looking at observability from a business perspective as well. Can we actually see the inner workings of our business? Like, from a business analytics perspective, can we see what success looks like? Can we instrument it appropriately? But then also with the teams, working with teams, can we see how well our teams are working and where the pain points for the teams are? So we're making that visible and obvious to the teams themselves, so that they can actually pull the hand on cord. You say there's a serious problem here. People are much less satisfied with the work they're doing, all that kind of good stuff. So it's one thing adding observability to your software systems. It's another thing, again, adding it to your system of work and the way you work. So What I do is I run workshops regularly with teams, specifically actually around the team's testing experience, to actually make visible a lot of the testing debt and challenges that they face in doing great testing in their teams.
What is testing debt? How is it different than technical debt?
I have a definition that I've been working on. So I define testing debt as when a team intentionally or unintentionally chooses an option that yields benefit in the short term, but results in accrued costs in terms of time, effort, or risk in the longer term, if that makes sense. Some examples of this. So sometimes we intentionally make choices to cut corners in terms of our testing in order to meet a business goal. So recently we had to meet a very time-bound business goal. We had 2 weeks to deliver a feature to probably our biggest customer. We delivered the feature within 2 weeks, but then we had to go back and add the observability, add the synthetics, add the end-to-end test, add all those things that we just simply didn't have time to do. So I'd done a lot of exploratory testing and stuff like that for this particular feature, but I hadn't the time to put all the other critical components in place that we need for long-term success of the software. So sometimes we unintentionally accrue this debt as well, right? So if we don't have a really deep understanding of testing and testability, testing tools, all this kind of good stuff, we may build our systems only after we've built them, realized that there's a huge cost in terms of how we need to test this. Very often what I find is that teams will build really, really hard to test systems, and it's only when we start testing them we realize that. So then you have to retroactively go back there and try and address those things, which is always more difficult than actually designing with testability in mind from the outset.
Right. Do you have any good examples of some common patterns that you've seen when it comes to implementing some architecture that makes it difficult? Like what does it mean to design software that's hard to test? Like,
I can give you a concrete example from 5 or 6 years ago. So I joined the company maybe 5 or 6 years ago as a test automation engineer, and they decided to start a brand new engineering department in Cork in Ireland, where I'm located. And so they were primarily a hardware-based company, but they developed kind of a proof of concept software solution that they decided was getting a bit of traction in the market. So they decided, right, we have engineers in the US, but we're going to build a team of about 35 people in Cork. So joined it, really exciting, really, really cool stuff, building a product that interacted with all this really cutting edge hardware. Really, really exciting. And as soon as we started, the first thing that the company asked us to do is, as I said, as a department of 35 engineers, was to regression test the product for the forthcoming release. So we jumped on board, all got involved in the testing, developers, testers, documentation, the whole lot. And we spent 7 weeks going through regression testing of this piece of software. And it was the most torturous 7 weeks of my life. It was painful. And it was late nights and weekends. And every time we introduced a fix, we broke 4 or 5 things in completely unrelated places. The automation that was there was flaky and unreliable. And it was actually built in such a way that it was dependent on the hardware we were testing against being available and in a known good state. The code was so tightly coupled as well. As I said, any changes in one place could break anything. So we had to do these mini regression cycles anytime we made the slightest of change. So it was, as I said, a torturous 7 weeks because the system hadn't been designed with testability in mind. So after that 7 weeks, what we did was, firstly, we had a bit of a break. I was sitting at my desk one day and the architect in the Cork office, he'd just been given the job kind of coming up with the new way we were going to approach development on our side, came over to my desk and he asked me one simple but very powerful question. He said, Rob, how can we build a system that's easy to test? And to be honest, I didn't have the answers right there. We went away and we talked about what challenges we faced when we were testing this. And because he was involved in the 7 weeks of torturous regression testing, he was really eager to avoid it. So we talked through the biggest testing problems, and I went away and I did some research. And what I came up with was a number of testability attributes that helped us design the system to make it more testable. And they boiled down to those things. To 4 things, really. I call it the CODS testability model. It's a mnemonic that basically describes 4 key testability attributes when you're designing the system. So there's the controllability, as I said, which was our ability to be able to control all the state of the system, to get it in all the interesting states we wanted to. Now, in our case, that was a huge problem, because we had no control over the hardware, right? So it was all located in labs all over the US, and we had no control over what state it was in and what kind of data it was sending back to us. So controllability was a huge problem. So when you're thinking about controllability, anything that you do when you're doing a test setup, when you're arranging your test, is associated with controllability. The next thing was observability, the ability to be able to observe the inner workings and understand the system. And again, this was seriously lacking in this case. we generally, when we're talking about testing, we're talking about the part where you evaluate or assert what's happening in the test. How easy is it to determine if there's a problem or not? That's the whole observability part. The decomposability, in the CODS model, is about breaking the system down into small, independently testable chunks. And the beauty of that is that you have nicely decoupled chunks of functionality in your system that you can test independently. So you can make changes into all these different components, knowing that you don't have to retest every single one as long as you abide by your contract. And lastly is simplicity, is the idea that you have a simple, easy to understand system with clearly defined responsibilities and roles, right? So it kind of ties in closely with decomposability, but you're looking at cohesion there. You're looking at having as few interactions, as few moving parts as you need, a very simple system. So we apply those 4 testability attributes. And what we ended up doing was building a completely new independent service for the first piece of work that we had to do, which was providing support for a new piece of hardware. It was a storage array in this case. So we had this completely new independent service that could be independently tested and deployed, and that sat away from our big ball of mud that lived there as it was. And what this gave us, firstly, was it allowed us to make all the changes that we wanted independently in our new service, knowing that we weren't breaking our big ball of mud code, and vice versa. But also what we did with the controllability and observability thing is we introduced 2 modes in this new service. We introduced the idea of a record and playback mechanism. So we could configure this new service to record all the interactions with the hardware component, dump them out into the file system as JSON at the very boundary or edge of the system as it interacted with the hardware. That's the observability part. That allowed us to see the raw data coming back from the hardware to understand were the problems being introduced by unexpected data come back from the hardware. And we could also see into the system or into the service to see how it was being processed and mapped and all that kind of good stuff. And then we had the playback mechanism, which was the most powerful part, which allowed us actually inject those files into the service to simulate all the interactions with the hardware. So we now removed our hardware dependency, so we could inject those files into the service to simulate the interaction. But more interestingly, we could now modify those files to simulate any possible state that hardware could be in. So we could simulate a fan being broken, an alarm going off, whereas before we were dependent on somebody in a lab pulling out a fan or breaking the system, which were located in labs across the world. So you can imagine how difficult that was to test. So now we had full controllability of every state that the hardware could have. We could see everything that was going on through the stack. It was independent of that legacy system, and it was really simple and easy to understand. So we went away and we designed and built this. And to be honest, the first time we did this, it took quite a bit longer than we expected. We were getting a bit of pushback and pressure from management. But we persisted, we felt we were going in the right direction. And what we found was that when we started working on our second hardware component, we were able to reuse so much of the functionality that we built for the first component in terms of the automation, in terms of just the infrastructure around the code. There was so much commonality between the first and second components. It was like we were able to get up and running in no time and reuse so much of it. But it also allowed us to do things that we couldn't have done before. So for the second component, it was a brand new component. We had no access to the hardware. And what we did was we simulated the interaction with the hardware based on the spec that we had and mocked out all that interaction, built the software, built the automation, had everything in place before we even got access to the physical hardware, which was light years apart from where we had been. Similarly, it allowed us to do very interesting things early, like we were able to mock out how the system would behave for, say, a max configuration of, say, 144 nodes in this case, when we physically only had, say, 3 nodes, and see how the system behaved. There's loads of other beautiful things that happened as a result of that. As you can imagine, the automation became really, really robust and resilient because all we had to our automation was now injecting these files into the service, simulating these various scenarios very, very robustly, very predictably. And our tests became really quick, really robust, giving us really great feedback, which freed up our testers then to do really valuable testing they'd never had time to do. They were doing all this stuff manually before. So now we were doing valuable exploratory testing, security testing, performance testing, and find a whole host of new bugs that we hadn't had the chance to do before. Similarly, the feedback cycle time for the developers free them to experiment and do things much, much, much more quickly. Like this, the feedback cycle times were days, if not weeks previously. And now every morning we came in, we had a huge suite of test automation that was giving us really, really robust, really good feedback. Then we had the exploratory testing on top of that was going deep, that was testing edge cases, resiliency, as I said, security, performance, and all these kinds of good things. But the last thing that really I thought was really amazing about this was when we actually had our first customer impacting issue with the first component that we'd released. So one of the customer support engineers came to my desk and he said, Rob, there's a problem with the storage array here. Can you help me debug it? So we basically SSH'd into the customer's environment, put the service into write mode, dumped the file onto the file system, copied it into our test environment, injected it into the service, reproduced the issue in minutes, patched the issue, retested it, and had it in place on our independently testable and deployable service within a matter of an hour. That would have taken weeks to have done prior. It was like an astounding change. It was really a light bulb moment for me. So ever since I had that experience, I've been focusing hugely on testability. It's really, really interesting to see how powerful a change and effect it can have on your ability to deliver frequently and valuable, really valuable software quickly and safely,
Yeah, I think you make a lot of good points in there about how when you have a good test framework in place and you've got good best practices amongst your team and you invest in that stuff early on, how it could help you speed up that feedback cycle and also to allow time for exploratory testing and trying to look for those edge cases early on, or even being able to do something before the hardware is even available. It's pretty amazing. So out of curiosity, how did you find your way into this type of work?
I started, as I said, I did electronic engineering in university, and I came out of the university and went to work with Intel in a semiconductor fabrication facility here in Ireland. I didn't find it very interesting, to be quite honest. So I went away, I traveled the world and decided to go into what I really loved doing in university, which was IC design for telecommunications. So I got a job with Ericsson. And this was in the year when 3G was just taking off. So I started working as a telecoms engineer in an R&D center with Ericsson and on what were called RNCs, radio network controllers. Unbeknownst to me, the role I was working in was actually a test engineering role, but I was like third line support in 3G telecoms at the time. Really, really interesting systems, really interesting tech, and a great, great, great company. So unbeknownst to me, I'd actually taken a job as a tester, and I really enjoyed it. Really enjoyed understanding the systems, trying to find the weaknesses and the frailties in systems. It was so complex a system, the volumes we were dealing with, that I just found it fascinating. So that led me into testing, and I was hooked from there. So I continued working in a variety of different companies then, medium-sized companies to startups. I worked some interesting startups, probably learned most of the startups, bringing me to where I am now, working in a mid-sized company that's growing really, really quickly. It's been an interesting journey. So I've gone from starting out in testing, working into automation, becoming like an automation architect, test manager, release manager, and now test coach, I guess, head of testing here in Poppulo where I work.
As I understand it, you're co-authoring a book right now with Ash Winter called The Team Guide to Testability. Who is the target audience for that?
The target audience is teams, is whole teams really. So it's not targeted at testers at all in ways, because the interesting thing about testability is that it's generally testers that feel the effects of low testability. They feel the pain, but it's not testers that can influence it very often. It's actually developers who can influence or design systems with testability in mind, and managers and people who make calls about how we invest our time and effort. So this is more focused at whole teams, at getting teams to understand the importance of minimizing their testing debt and designing testability in, because ultimately the level of testability that you build into your system determines how quickly you can move with confidence. Like anyone can write code really, really quickly and ship it really quickly, but most likely it'll break. When you actually care about quality and delivering a decent product, you need to focus on building testability in, and that allows you to have those really, really good fast feedback loops that give you the confidence to ship frequently and ship soon. And again, a big part of testability is the observability part in production, the ability to be able to put it out there, either do canary releases, feature flags, control the release of this, manage the risk, and also have the observability stuff in there to know when there are problems in production, to know that we should actually toggle this off and all that kind of good stuff. So I think it's Kelvin Henney talks about why do cars have brakes. I see testability like the brakes for our cars. For a high-performing team, you want to have a focus on testability to allow our teams to go really, really, really fast, because it's our testability and the testing that it provides that allows teams to go fast, because you have those signals to tell you very quickly when something's wrong.
Do you find that observability in another way of like being able to quickly debug things, do you think that's a good way for developers that may not understand observability, just be able to like go in and like see like either a paper trail or some breadcrumbs of like what happened in this scenario?
Exactly that. So it's all about debuggability, really, in ways in your system. So let's say, for example, I can give you an example. In our systems, you may have a problem that occurs intermittently. You'll see in the data there seems to be an increase. If you can split your data by your customer or by the browser type they're using or by some other interesting piece of information, you can quickly identify, is this a problem that's only affecting a certain cohort of your users? So observability allows you to slice and dice your data really quickly and easily to identify the root cause of a problem. So it's more about understanding what the cause of a problem is. Monitoring, on the other hand, often identifies the symptoms. So when we build our monitoring, we usually focus on our end users and their pain points. We put maybe synthetic monitoring or synthetic tests in place that run in production to tell us when a core piece of functionality doesn't work or something like that, or we analyze the error rates, or we analyze the response rate or the response times, and we monitor that, and that tells us there's a problem, but it doesn't tell us what the root cause of the problem. Observability is the tooling that allows us to isolate what the root cause of that is. It allows us to debug it, slice and dice the data and say, this is only occurring for users of IE11 in the US that are customers that use this product, for example.
And can this type of data also be used by your team, like product owners or whoever on the roles that you might have in your organization, to help determine when, say, features or certain aspects of the application are being underused or no longer worth maintaining or supporting, maybe need to get ripped out at some point?
Yeah, so I call them retirement flags. The technique I use around this, or I want to use around this, should I say. We haven't done it yet. So the idea there would be to actually look at the usage of the various parts or components in the system. You can use data analytics tools and the likes of Google Analytics and things like that for that too. But certainly observability can be used to determine how your system is being used, how frequently it's being used. And then theoretically you could introduce, as I said, retirement flags, which are a bit like feature flags in reverse, whereby you can toggle it off and see if anyone complains. And if someone complains, maybe you could toggle it back on easily. But yeah, certainly that can be used for identifying areas of the code that aren't used very much. But it can also be used to identify areas that are used probably unexpectedly too much, and basically allowing you to get an insight into how your system actually behaves, how your users actually experience it, as opposed to how you imagine it does. So it's giving you real data. It's giving you a real feel for. When you think about the monitoring, as I said, monitoring is binary. It's either there's an alert, there's a failure, or there's not. Observability, it gives you resolution to that picture. It allows you to go in there and ask questions and understand, is it certain types of people who are having problems? Is it everyone? Is it a really significant problem? Is it a small problem? And all those kinds of things.
We'll be back with my interview with Robert Meaney in just a moment. Hi, it's me, Robby. I wanted to thank you for listening to the Maintainable Software Podcast. If you're finding these conversations valuable, please consider sharing it amongst your peers and friends and loved ones, and writing a review on Apple Podcasts to help spread the word. Also, if you have a good story or two to share about ways to improve the long-term maintainability of software and might be interested in being a guest on the show, please get in touch with me at Robby with a Y at maintainable.fm. And now back to our interview with Robert Meaney. I want to circle back around to something you brought up earlier on in the conversation about helping developers when they're going through some sort of sprint planning process or something, but when you mentioned helping them break down stories and trying to assess risk in those stories and figuring out how they're going to go about approaching building something. Can you give me a recent example off the top of your head, if possible, on a way that you were able to help a developer think differently about how they were going to approach the implementation?
Yeah, so I have a model I use with most of the teams that I work with. So, as I said, I rarely work directly. Well, sometimes I pair with developers and stuff like that, but usually I work at a team basis, and okay. I have sessions and I work together with the team. And one of the models I use I call risk mapping. And what it does is it asks 5 pretty simple questions. The first being, how will we know if we've broken any of our existing functionality? So the risk is we've broken our existing functionality. What can we do to mitigate that? Do we have adequate existing unit tests, integration tests? Do we need to add extra ones here? Do we need to do some exploratory testing and all that kind of good stuff? So I work with them to explore that risk. Then I move on to acceptance testing. What are the things that we need in place to know that this new functionality can work? So do we have acceptance tests in place? Are we going to do user acceptance testing? All that kind of good stuff. Again, it's unit testing, integration, maybe end-to-end tests, a few bits and pieces like that. The next thing then is the human element. Are there problems that only a human will find? So as I said, the regression testing and the acceptance tests are things that are pretty automation heavy typically. But then I talk about things only humans will find, the usability side of things, those quirky, weird things that only users uncover. So then we talk about, do we need to run a bug bash? Do we need to do a chartered exploratory testing session? Do we need to, depending on the context, different approaches will work. So one of the products we have is a mobile product here. So this is very important in this stage because diversity of data and the diversity of device that we need to support means that a bug bash with, say, 50, 60 people involved can be very, very powerful in unearthing weird little UI issues on the different screen sizes and devices. But also people have different perspectives and use products slightly differently, and they have, some things are really tricky from their perspective that as a developer who's developed this, you just don't see. The other side of this then is operability. Will this new feature work when we deploy and release it into production, and will it continue to work and scale? So this is all around the observability stuff. This is all around scalability, performance testing, stress testing, benchmarking, everything around operations and ensuring that when it's in production, it runs well, and we know it's running well and working well. And the last one then is around recovery. It's like, how do we know the system will behave relatively gracefully in difficult circumstances? So we work through those risks there in terms of if we take the service down, if we restart services here, there, and everywhere, if there's latency, if there's a dependency that becomes unavailable. We work through those scenarios and we talk about how we can mitigate those risks. We could have chaos testing, but it's all about the instrumentation. Interestingly enough, it's about the instrumentation and the infrastructure and all that stuff as well, right? So one interesting example I had recently where I did this exercise with a team, the tester on the team subsequently went in and he did some load testing against the service. I was suggesting that he hit it with the load testing tool with malformed JSON. And what happened was when he ran the test, it took down one of the infrastructural monitoring tools, which was very interesting. So we have to think more than just, this is the source code. We think about the infrastructure that supports us, that allows us to monitor it. All that kind of good stuff has to be tested, and there's risks there too. So when I ask those 5 questions, it allows us to kind of go full circle on all the different types of risks, and it uncovers a lot of the things people typically don't think about, because people think that, I ship it to production and I walk away. But in reality, huge amounts of effort are expended on maintaining, debugging stuff in production, and recovering from problems and all that stuff. So we have to think about them when we're building the stuff up front. And exercises and models like this help teams to start to consider that very, very early in the process, so that when we're designing it, putting the architecture together, we're thinking about how we can operate this production. When something fails, which is inevitable, how are we going to recover?
You mentioned a bug bash. Is it a safe assumption that you're getting a bunch of people together and just try to use the product? And
yeah, exactly that. So as I said, the software is built by humans for humans. So the best way to detect these kinds of problems, often, the problems that only humans will detect, is get humans using the product. So typically in our teams, especially the UI heavy ones, we do our exploratory testing in the team. So I'll go in and a tester will go in and explore the product, uncover problems. And then once the story has been explored, maybe we'll do a mob testing session as a team. So basically it's a bit like mob programming. You have a navigator, and then the team will kind of issue instructions, and we'll test as we go, which is great because the whole team gets to see and challenge the software and take ownership of that. And the next level then beyond the team is really maybe getting a bug bash going, where you get a group of people from across the business go in and either spend a time box period just using a new feature, or else sometimes, if it's quite complex, we'll give them different tasks that we want them to complete, because you may want to get coverage of different flows and feedback. And during the bug bash sessions, we encourage people to raise any questions, concerns, any particular issues that they encounter. And it's a really, really effective way of kind of uncovering all those weird gotchas that You're not going to catch with unit tests. You're not going to catch with integration. It's a really powerful tool, especially for UI-intensive applications.
You've been sharing a lot about how in an organization that has a number of products and different teams working on these different products, and I see that as a very mature environment where they're able to invest in a lot of quality and such, where I know that sometimes in startup mode, you may not have the access to some of the same financial backing to be able to support the budgets for that sort of environment, at least not yet until the business can prove itself, unless it's gotten funded or something. And I know that a lot of people that are potentially listening or maybe working on some small development teams, and they're like, well, we don't even really have any automated testing at all yet, but we're looking to start exploring that. And maybe should we be looking to hire a tester? Should we be learning how to become testers maybe in the first place? So, for those types of people, what advice might you offer them on how to start exploring those next steps there so they can start working to become a more, maybe from our perspective, have some more mature processes that improve the reliability and stableness of their applications?
The exact problem that you described there, as I said, we have here too. I think it was Ken Beck talks about 3X and, the explore, expand, and exploit problems. So there's three different phases. The explore phase, you're typically experimenting. You're doing quick and dirty experiments to try to achieve product market fit. Then when you hit product market fit, everyone wants to use it and you have to deal with a different set of problems. They're typically scaling from a technical perspective. So you hack something together to get it to work, and now all of a sudden everyone wants to use it and it can't scale. So there's a different set of problems there. And then the extract part is really around return on investment and efficiencies and all this kind of good stuff. From my perspective, if I was to give advice to a startup, and I've worked in startups myself, I would encourage developers to build their testing skills, because testing doesn't solve your quality problems. Adding more testers to a quality problem is a bit like throwing petrol on a fire. The more testers you add, the more problems they'll find. The more problems they find, the more problems they'll have to fix. And you're relying on the same system to fix the problems that introduced them in the first place. So ultimately, if you want to solve a quality problem, you need to focus on quality from an engineering and a management perspective. So my advice would be try and understand when's the right time to invest in quality. As you said, I would actually focus on building the testing skills within the developers themselves. But also you have to balance the investment you put into testing and quality, resilience and all that stuff with where you are in that 3X cycle. Because if you're doing quick and dirty experiments to determine whether this business hypothesis is even feasible, there's no point in investing in huge amounts of test automation, unit testing and all this stuff. However, as you mature through that cycle, you have to ask different questions. When you start having paying customers, that's probably the point at which you have to start talking about resiliency, quality, and asking some serious questions about this stuff, because people depend on your software. It needs to be reliable. It needs to deliver value. And if it doesn't, they're not going to continue to pay for it. Start out, quick and dirty experiments, get market traction. When you get market traction, then start asking some questions about the operability type stuff I was talking about. How are we going to operate this in production? How will we know if our system's healthy? How will we know when it's unhealthy? I'd actually start with observability before I'd start with testing, because when a team focuses on observability, it allows them to get an understanding of where they are and where they need to focus. So build observability, and at that point, understand where your problems are, and then go and address those problems and iterate from there and find a process that works for you. If you bring in a tester, as I said, a tester will go and do a great job testing, finding problems, but you need to change the mindset of the people building the software in the first place. So in ways, you're papering over cracks. So I definitely suggest, maybe if you want to bring in trainers, bring in people that can ask those kinds of questions I'm talking about. How will you know when your system's unhealthy? When your system is unhealthy, how will you be able to identify what the root cause of that is? Okay, let's do some retrospectives on these customer impacting issues, find out what the cause of those issues were in terms of a systematic way, blameless way and all that stuff. And let's try and identify the root cause of these problems. And then you start seeing practices emerge specific to that context that makes sense from a testing perspective. Maybe it's mobbing, maybe it's TDD, maybe it's whatever, but that can emerge as you learn, as opposed to going in and dictating, everything has to be exploratory tested, everything has to, each context and each team needs to find their own way to, and that's why as a test coach, I talk about quality goals. What do we actually want to achieve? What does good look like? And then I work with the team to find a way that works for them to achieve those goals. So as opposed to going in with a stick and saying you have to test everything this way, this way, and this way, because developers are hugely creative and innovative creatures. If you give them a goal and give them a problem, they'll find really interesting ways of solving that me as a tester, I won't come up with. And I've seen this throughout my career. I go in and ask questions, we find a problem. Like, for instance, I did an exercise with one of the teams where it was an observability one. I went through each of the significant components in their system and said, how will I know if there's a problem in this component, in this component, in this component, in this component? And one of the components, which was the client-side app, they had no way of knowing if there was a problem being introduced there. Now, unbeknownst to me, one of the developers on the team went away and did some research. He found a tool called Sentry. He integrated it, and all of a sudden, we're seeing exceptions being generated in the client-side app. So I would never have suggested Sentry, but I could ask the question. And as I said, someone far more cleverer than I could go away then and find the appropriate tool and find a way of solving that problem that I wouldn't have.
I just like touch on a couple of quick little things. You talk about, you mentioned like Sentry and tools like that. With all the third-party testing software tools that we have available today, do you think it's more or less complicated to maintain software now than it was, say, 10 to 15 years ago?
No, I think it's actually easier to maintain it now, because I'm thinking back 10, 15 years ago when I had racks of computers, for like localization testing and testing with different setups. And I physically had computers and I had to power them on, wait for them to boot and all this. You got containerization, you got so much stuff now and so many frameworks available. And like even things from a testing perspective, you've got things like Sauce Labs, you've got all this cool stuff now where you can I want to do browser compatibility testing. I spin up Sauce Labs and I have every version of IE and every version of Firefox, every version of Safari at my fingertips. Whereas I said 10 years ago, I was getting physical boxes out, powering them on, installing browsers and all this kind of good stuff. So like every day I'm discovering new cool things that allow us to do a better job of testing. So it's definitely easier now than it ever has been. There are still huge challenges, but there's so many cool tools and approaches and all that kind of good stuff out there. I'm just scratching the surface. There's, I'm sure, like, as I said, I discover something new every day and I'm kind of going, oh my God, how did I ever work without that? So there's really, really cool stuff emerging that just allows us to do really, really cool stuff. The legacy thing is a tricky one then, and dealing with that and the maintainability of that and actively cleaning as you go and trying to make code more modular and all that kind of good stuff. The big challenge from a testing perspective often is that we've got these huge banks of UI tests that run and they're hugely flaky and all this kind of good stuff. So one of the initiatives that I'm working on at the moment is around moving from our reliance in our legacy code base on those end-to-end UI tests, which they're hugely effective and powerful, but hugely costly in terms of, you have to build and deploy the entire system, you have to run all those tests, you have to debug all those tests, and all that stuff. So trying to shift the focus from relying on these UI tests to actually going back and building testability into that legacy code base and making it more modular and adding in endpoints for testing and all this kind of good stuff. And by bit, we're making improvements there. But I'm sure everyone faces this problem, is getting the balance right between working on new valuable features and taking time out to actually address technical debt and testing debt and all that kind of good stuff.
All right, and time for just two quick questions. What book do you find yourself most often recommending to, say, software developers?
Yeah, from a testing perspective, I'm a big fan of Lisa Crispin and Janet Gregory's book on agile testing, and the second one as well. Both very, very good books to pick up, and you can leaf through them, and you always find something interesting. They're funny books in that I've read them, and every now and again I'll dip in and I'll read something again and go, oh my God, how did I forget this? So hugely powerful books if you want to get familiar with testing and agile testing and all that stuff. They'll talk about all those approaches that I talk about to do with breaking stories down into small testable chunks, bug bashes, exploratory testing, all that good stuff, all those practices. For me, it boils down to a few critical things from a testing perspective. It boils down to systems thinking, critical thinking, risk analysis, and exploratory testing, and then the whole thing around observability and testing in production. If you can nail that stuff, you're doing pretty well.
Great. And where can people learn more about you and follow you online?
Best place is Twitter. Yeah, so my handle is @Rob Meaney, and I am prolific on Twitter, probably too much so, for my own good.
Well, great. Well, it's been such a delight having you on Maintainable, Robert. I appreciate you joining us.
It's been an absolute pleasure. Thank you so much for giving me the opportunity to talk at length about testing and testability.
Much appreciated. Thank you so much.